Hello, my name is Saif Aboudanin, and I'm a senior studying electrical engineering.
For optimal healing following critical bone injuries, it is necessary to gradually start putting weight on the affected lower limb and progress to full weight bearing over the course of the recovery period. Orthopedic surgeons instruct patients to approximately apply a percentage of their body weight onto the affected leg, depending on the phase of rehab. Most patients find it difficult to know the exact amount of weight they're loading onto their limbs, and thus resulting in overloading the injury. My thesis project is to design a device to be incorporated inside forearm crutches to measure weight exerted through the crutches and compare it to a predetermined threshold. By using force sensors and haptic motors, the user will get an instantaneous feedback if they're applying too much or too little weight on their affected limb. Having such feedback instantaneously would decrease the chances of overloading and therefore result in more efficient and effective rehab.
Bicycling still represents one of the best options available for societal improvement. Bicycling for transportation combats a whole host of potential health problems while simultaneously helping combat climate change. A true win-win. Despite this, innovation in children's bicycles seems to be lagging behind the industry. If we hope to affect societal change for a cleaner, healthier future, it is necessary to instill enthusiasm in those who will change the world tomorrow by making it fun, easy, and as painless as possible to make those changes. The Convertible Beginner's Composite Bicycle.
Biomaterial-based immunotherapies have shown great promise for the treatment of cancer. Their efficacy depends on the ability to induce dendritic cell activation and maturation. The goal of my project was to design a biomaterial whose adhesive cues are optimized to promote maturation. For this purpose, I fabricated a hydrogel consisting of alginate modified with RGD adhesion ligands. By reducing the RGD degree of substitution, I observed a significant increase in mature surface marker expression and inflammatory cytokine secretion. These findings can be used to inform the design of more effective dendritic cell vaccines.
A major challenge faced by the information technology sector is the ability to store memory more efficiently. The use of electron spins in modified diamond samples to represent quantum bits is a promising solution. This project involves creating an integrated system to observe and manipulate the electron spin states and assess diamond for spin characteristics. The future applications of such a system include GPS and digital signatures. Storage, smaller than a chip.
Hello, my name is Andre Dupuis, and my thesis is about optimizing the detection of lower stratospheric CLO and BRO concentrations. As you may know, ozone is crucial for the habitability on our planet. Studies have shown the anti-correlation associated with chlorine radicals such as CLO and ozone in the lower stratosphere. This has far-reaching global health implications due to increased cases of skin cancer. My thesis focuses on optimizing an instrument to measure in situ concentrations of CLO so that we can better understand atmospheric chemistry related to climate change. So come on down and learn more.
Worldwide, approximately 10 million people live with limb loss. Many people with lower limb amputations use a prosthetic leg like this one. The key to a good socket is reducing pressure and shear of our bones, but current systems to measure these stresses are bulky and rigid. For my thesis, I've created soft, flexible sensors that measure pressure and shear. When integrated seamlessly into a prosthetic liner, these sensors will be used to design sockets that reduce painful pressures, hopefully enabling more people to find comfort in walking.
My name is Wesley Fabian, and my project is fabrication method for the production of a cardiac microtissue-laden bioink with 3D printing applications. A myocardial infarction can result in the death of up to 1 billion cells. This is a problem because the heart is not regenerative. However, stem cell-derived cardiomyocytes leave the possibility of cell therapies for treating myocardial infarctions. The current problem is that engineered cardiac tissues either express poor alignment or are unable to be harvested and used for cell therapies. Therefore, my goal is to create a protocol for generating highly aligned and harvestable cardiac microtissue building blocks to be used to develop a bioink that can 3D print cardiac macrotissues in the future. My overall approach is to seed cardiomyocytes and fibroblasts in a micropost construct to create microtissues to be collected for the bioink. To learn more, please come to the ES100 poster session.
Hawaii's high dependence on food shipments is drawing greater concern for the future of food security in the islands. Possible solutions look to more traditional agriculture like taro or more conventional crops like corn. The best path forward for Hawaii will need to capitalize on both land and ocean-based resources. My model will be based on a series of differential equations and will evaluate the influence of runoff from different agricultural practices on fish pond aquaculture productivity.
My name is Daniel Galindo Navarro, and my ES100 senior design thesis is Lifting Smarter, correcting exercise form using inertial measurement sensors. Back posture and form is one of the most important parts of doing exercises such as deadlifts and squats, to both get the most out of the exercise and prevent injuries such as herniated discs and muscle strains. For my thesis, the goal is to help athletes reduce the risk of these injuries by learning to maintain better back posture during lifts. My project uses inertial measurement sensors comprised of an accelerometer and gyroscope to measure the curve of the spine, as well as using targeted haptic and auditory feedback to alert the athlete of when back posture deviates from normal.
Hi, my name is Rebecca Gracia, and for my senior capstone project, I am working with the Harvard Ceramics program to develop a modern wood-fire kiln. What makes my design unique is its economical approach to implementing a system of automated vents, which control the internal atmosphere to produce a variety of aesthetic finishes. I've conducted various structural and thermal analyses to optimize the performance and cost of the kiln overall. I've truly enjoyed combining my interest in art and technology over the course of this project.
Hello, my name is Patrick Hansen, and in my ES100 project, I use specialized hardware to reduce the power consumption of deep neural networks I trained for a speech classification task. Please stop by to learn more.
Hi, my name is Jenny Mooring, and my thesis is a foldable wing design for obstacle avoidance for micro-aerial vehicles. Despite the vast improvements made in aviation, fixed-wing drones still lack agility and flexibility. I am trying to incorporate Harvard Microrobotics Lab technique of composite layering to create origami folds in the wings so that drones will be able to change their wingspans mid-flight while still creating enough lift to support itself.
In the realm of atmospheric research, experiments can be conducted in fairly extreme environments. It can be difficult to predict the exact behavior of scientific instruments without prior laboratory testing. So, in my senior capstone project, I am designing and fabricating a thermal shroud, a thermally controlled chamber that mimics the conditions of the stratosphere. I designed a simulation that couples heat transfer and fluid flow to confirm the effectiveness of my design. Stop by my poster.
Hi, my name is John Rahill, and for my ES100 project, I am generating seismic waves and using geophone receivers to uncover the depths of wooden foundations. The application is right here in Boston. Wooden pilings that lie under many buildings downtown have suffered rotting issues in recent decades by being exposed to air. Since the exact depth of these pilings is mostly unknown, I hope my method will make this measurement easier and help home and building owners avoid serious structural damage in the future.
Smart devices are revolutionizing our living spaces. Machine learning is driving change in virtually every industry. In this project, I harness the power of machine learning to develop an even smarter smart device. The learning humidifier uses supervised learning to adjust the humidity to suit the user's preferences. This means no more worrying about setting the right humidity level. This humidifier ensures that your room is always comfortable.
Hi, I'm Chris Marquez, and my project is on an atmospheric water generator using regenerable hydroscopic materials. Due to the effects of climate change and pollution, sources of fresh water are becoming increasingly scarce. To combat this, researchers have been trying to extract water vapor from air using condensation in order to produce a reliable source of drinking water. How can we do this? Through the use of zeolites and other hydroscopic materials that have the perfect pore sizes.
I'm creating a wound dressing for the treatment of diabetic foot ulcers that interfaces with the immune system to improve healing. My wound dressing biomaterial is composed of biocompatible alginate and utilizes the protein binding capabilities of heparin to control the release of cytokines into the wound bed. These cytokines can then recruit and activate immune cells in the body that are in deficient populations in diabetic patients to better heal the wound. My work is focused on designing, developing, and testing wound dressings for their cytokine release profiles and physical integrity as an immunostimulatory bandage.
Hi, my name is Nicholas Ontiveros, and my senior capstone project is a low-cost, multi-effects processor for electric guitars. So electric guitarists often want to modify their sounds in creative ways via implementing a variety of different audio effects. And so what my project does is it allows a guitarist to either write their own digital signal processing code or to use existing libraries such that they can modify their sounds in a variety of ways and do so in a very easy and flexible manner.
Hi, my name is Hunter Richards, and for my Environmental Science and Engineering Senior Project, I worked to create a living wall using clay ceramics, alginate hydrogel, felt, and moss that can reduce urban air pollution. My living wall is cost-efficient and sustainable, with components capable of taking up pollutants, absorbing heavy metals, and reducing other airborne particulate matter that causes significant health concerns in urban areas.
Fence lines are an essential component of all farms and ranches. However, building fences can be both expensive and physically straining. The goal of my project is to design and build a machine that will eliminate the most physical parts of fencing. My machine combines existing components with a few components of my own design. If you would like to learn more, please attend the upcoming poster session, and I would be happy to talk with you.
While traditional cancer treatments kill both healthy and cancerous cells, cancer immunotherapy seeks to harness a patient's own immune system to target tumors. This approach seeks to have antigen-presenting cells present small peptide antigens to T cells to elicit an anti-tumor immune response. RNA is cheaper to produce compared to peptides, but relies on diffusion to target cells. Using a scaffold that recruits millions of these target cells, it's possible to enhance delivery of the mRNA to the target cell. The goal is to have sustained release of mRNA from the scaffold, which is taken up and translated by target cells and presented to T cells to elicit an anti-tumor response. Using liposomes, this system has demonstrated sustained release of mRNA, which is promising for its application in an RNA-based cancer vaccine.
For many years, yeast has been employed in industrial fermentation processes due to the low cost and safety for human consumption. Even though technological advances in the fermentation industry have had major developments, one of the greatest challenges is the observed low carbon yield of the product of interest, a problem generally addressed through intensive genetic engineering of the microorganisms. In this project, we investigate a highly cytocompatible metal-phenolic network composition that inhibits cell division while simultaneously maintaining cell viability and functionality. Coated cells can more efficiently use nutrients and effectively produce desired metabolites.
Currently in the United States, hot beverages are served at scalding temperatures. Even brief exposure to drinks at these temperatures can result in terrible burns. For my ES100 senior design project, I'm creating a travel thermos that'll take in drinks at this really hot temperature, bring them down to an ideal drinking temperature, and then maintain them at this temperature for a prolonged period of time. This mug is being created without any electronics and relies solely on the intrinsic properties of the materials I'm using.
Hi, my name is Scott Sun, and my engineering thesis involves designing a high-voltage power converter for driving capacitive actuators, such as this dielectric elastomer actuator, which deforms when you apply over 500 volts to it. Typically, this is done with a large, bulky power supply, but instead I need to use a tiny 3.7 volt lithium polymer battery and a circuit that looks something like this to boost that voltage up to 500 volts.
Amidst these troubling facts, there is hope in the fact that the atmosphere contains over 3 quadrillion gallons of untapped water. That's enough water to supply the water needs for the entire planet for a year. Stop by to see how I plan to help alleviate the global water crisis with my low-cost atmospheric water generator, which will operate at the cost of 2 cents per liter.
Soft robotic exosuits provide increased mobility to healthy and physically impaired individuals through gait assistance. To provide effective, individualized biomechanical assistance, the exosuit must work in parallel with the specific movement of each user. Therefore, a real-time ultrasound system is being developed to identify and track muscle and tendon features to determine force and timing of actuation by identifying gastrocnemius concentric contractions in the push-off phase of gait.